Hi, welcome back. Let's continue with our cloud journey. In the last 7 episodes, we've covered basics of creating a Windows Azure cloud service. Now, I think we're ready to take on a more serious project. When I planned for the course, I had several candidate projects, but eventually I decided to go with Azure Trivia project. Azure Trivia is an online multiplayer question and answer game. It supports different playing modes. In single-player mode, you can practice your skills in either practice sessions or ranked sessions. The scores from practice sessions are not tracked. The scores from ranked sessions are saved on the server, and you can compare your scores with other players around the world. Each ranked session has 20 random questions, and you get 20 seconds to read and answer each of the questions. You can also trace your progress over time. In two-player mode, you can either participate in randomly assigned duels, or you can invite your friend to play head-to-head. And finally, there will be periodical multiplayer tournaments where players are randomly assigned in duels till there's a final winner for the tournament. Azure Trivia starts with a small question library, and everybody is welcome to contribute to question libraries by adding new questions or fixing existing questions. Of course, you can also report spams and abuses. The system also automatically tracks the difficulties of problems and present different sets of problems based on your levels. That's the plan, and we are not going to start from scratch. Because Azure Trivia is a game, there's a lot of work going into graphics and animations. I don't want us to get distracted by those details. Instead, for each episode, we will have a start project and we'll work through towards the end project. You can find links to the starting project and ending project in the post of each episode. For this episode, we'll start with a version with single-player practice sessions implemented. And now let's see how it looks like. This is the UI of Azure Trivia. As you can see, we only have one practice link here, but you can imagine in the final version, we will have many more links for different playing modes. You can move your mouse around and see how the UI responds. This UI is based on HTML5, so all the graphics you see here are actually painted on the canvas. Let me click on the practice link, and this takes you to the practice page, where you can practice as many questions as you like. For instance, now the system is displaying a random question. I can make a choice, then click on confirm. Then the kitten will tell me if I have answered the question correctly, and then I'm taken to the next question. You can see I answered this question wrong. And you can see for many questions, there's a book besides the kitten. When you click on the book, you're taken to another browser window where you can learn more about the question. The practice sessions are anonymous. You can see number of questions you've answered and the number of questions you've answered correctly. So this is our starting point. We have a very simple feature implemented, and we'll go from there. Now let's take a quick look at the system architecture at this point. The beginning architecture is very simple. On the left side, we have user interface. The user interface is built in HTML5, and we use jQuery to call into our backend APIs. We also use MVVM pattern on the client. Here I chose to use Knockout.js library for UI bindings. On the server side, we have an API layer, which provides all the functionalities the clients need. We also have a question repository, and in this initial version, it's a simple XML document. Now let's have a tour of the source code. This is the beginning solution. We have a Windows Azure Cloud Service project here. It contains one web role, which is our Azure Trivia website. And I'm saving all the domain objects in a separate class library called Azure Trivia.entities. You can see here I've defined several domain objects, such as a choice, a question, a reference to an internet source. The web role is the ASP.NET MVC4 application. And currently I have two views defined. One is the home view, and the other is the practice view. Let me open the home view. For the home view, the UI is a single canvas element in the div element. And I have a canvas view module class, which defines the abstraction of what I'm going to paint on the canvas. And I have a screen painter class, which encapsulates all the screen painting functions. After the page has been loaded, I will first initialize the view module. Then I will bind the view module to the screen painter. Then I will bind the screen painter to my canvas element. Now let's see the practice page. The practice page is a bit more complicated. I have a canvas where I paint all the graphics, and have a table where I bind my current question to, and I have a div to indicate if the system is busy reading data. You can see the UI part is kept very clean. There's no mixture of HTML tags and JavaScripts. All data to be presented are bound to UI elements through the knockout.js data binding. And although this page looks very different from the home page, but it follows the exact pattern. Let me scroll down a little. You can see here I have a list of view modules representing different entities. At the top, I have a page view module which represents the abstract view to be bound to HTML elements. I also have a canvas view module which represents all the graphics to be painted on canvas. And similarly, once the page is loaded, I will initialize the view modules. Then I will bind canvas view module to screen painter, and then I will bind page view module to HTML elements by using knockout.js data binding. In this case, I'm also subscribing to several property changed events of my view module, so you can update the UI accordingly. Then at last, I will bind my screen painter to the canvas. This is an example of keeping separation of concerns. Although the UI is very dynamic and complex, but you can see here I maintained separation of concerns. My HTML tags are not mingled with my JavaScript, and my view modules never manipulate the UI directly. And the UI knows nothing about the backend API. And at last, let's take a quick look at the question repository. I have created a repositories folder, and all question repositories implement the same interface. iQuestion repository. For the initial version, I have a mock repository for testing only, and this mock repository reads questions from a local XML file, questions.xml. In this file, I have a bunch of questions. Each question has an ID, has a correct answer, has text, and it has 2 to 4 different choices for you to choose from. And some of the questions have additional reference elements. You can see here I have a MSDN article which provides additional information about the question. So that's a quick introduction of the project, its architecture, and its source code. Starting from the next episode, we'll start to improve the system by using different Windows Azure services, and we will implement the features we mentioned at the beginning of the episode. And along the way, we'll also discuss the difference between a cloud service and a regular website, and we'll discuss different principles and techniques for designing a highly available, highly scalable cloud application. I hope this would be a fun project for everybody. Thank you for watching. I'll see you next time.